Okay. Hello, my name is Irina Rabayev, and it's my pleasure to welcome you all to today's Digital Humanities Seminar. We are honored to have Professor Jihad El-Sana from Ben Gurion University of the Negev as our guest speaker. Professor El-Sana is a distinguished figure in the field of computer science with a special emphasis on computer graphics, image processing, augmented reality, computational geometry, and document image analysis. His contributions to the field are vast and varied, with highly cited publication in areas such as adaptive real-time rendering, automatic reconstruction of tree structures, view-dependent simplification, and terrain rendering. Professor El-Sana is notably a pioneer in the analysis of Arabic historical document images. He has defined and introduced several critical problems in document image analysis by effectively translating complex humanities challenges into computationally solvable questions. Through his leadership, several datasets for Arabic document image analysis have been published, fostering open research and benchmarking in the field. His work has earned him awards in document image analysis competition, and he and his team have hosted competitions in leading conferences in the field. In addition to his work on Arabic documents, Professor El-Sana has made significant strides in the analysis of historical Hebrew documents and Hebrew paleography. His contribution to the Hebrew paleography include developing methods for script type and mode classification, hard and soft labeling, and creation and curation of valuable data sets like Hebrew paleography datasets and Pinkas dataset. Today, Professor El-Sana will enlighten us with his talk on Palimpsest reconstruction using synthesized datasets. Thank you, Jihad.
Okay, thank you, Irina. I think for the nice words. Today I would actually talk about most of the work you have said, Irina, was actually done in collaboration with very good students. So it's practically without them, it will not be possible to do this work. Today I'll talk about the work which was done by Burak Madi. A student is about to finish his PhD now. This is one of his actually papers, was published just recently. And so first I will talk about, will be the outline of my talk. So first of all, I'll introduce our group and lab, what we are doing, and then I'll talk about the introduction of the problem and how we define it, and the data set we use, overview about it, and then about the deep learning model, and then evaluation, visual results, and summary and conclusion. So I'll start it with the Visual Media Lab. It's actually one of the groups that actually sit in the lab of visual media, and they actually work in image processing, computer graphics, 3D graphics, augmented reality, and a lot of work actually in document image analysis, starting from text classification, word spotting, paleography analysis, text line extraction, text alignment, writer identification. And I actually have the group consists of two kind of people. One is actually collaborators who are either a researcher in other institutes, and we are closely collaborate to each other, and actually we hold a weekly meeting in at least some project they participate in, and these are the current students, and there is a lot of students who contribute to this work, so I'm just mentioning their names. And when we talk about parchment, it's a writing material that used for some period of time over the history, made of skin of animals, usually mainly sheep, goats, and cows. And due to the lack of this material, because it's expensive, first of all, you need from animals, living animals, and also the process of actually taking the skin and putting it into as a writing material is also complex procedures. So in order to, because of the lack of such material, people used to scrap it and wash it off in order to reuse it for writing. And this create what we call palimpsest. Is practically the washing of and the scrapping of the skin is not perfect, and the washing is not perfect. So there is tracks of the underlayer text, and then when they write in the top of in the top layer, there remain parts of the text that we can actually use and try to reconstruct the original manuscript. So this is the parchment that include at least 2 layers of text. We call it palimpsest. And it has been quite famous, some of them. The most famous is the Archimedes palimpsest, which shows some a kind of a document that was the underlying document which talk about the Archimedes studies. But there is a lot of a manuscript like palimpsest exist and discovered in various places. And the interesting things about this, they shed a light on a very kind of early period of writing. So this is one of the things that when people try to understand, it's before the use of paper. And this is one of the things that it actually tell us a story about kind of like time in history, which are far before the paper. So this is why it's interesting to recover its the structure. Now, there's 2 approach in order to recover the manuscript. One approach is to try to recover the visual appearance of the manuscript before washing and writing the upper layer. And practically, this kind of approach kind of like consider this as a piece of art in order to recover how this kind of like piece of art looked before washing and scrapping it. The other approach trying mainly interesting to recover the content, which is the text. And the idea that the text to recover the text to the point that this text could be read by human or machine. So here what we see, like these people are interested, for example, in the text. Now, these kind of like there is a lot of challenges in these texts. One is actually there is a color degradation in the both the background, the under like layer and the overlayer or the upper layer, and there is a faded ink for both the upper layer and the lower layers. It's also there is a complex kind of like a intersection between the letters of the upper layer and the lower layer, and often this is make kind of the under text layer is not really the letters are fragmented due to the occlusion by the upper layer. So this is the main challenges in such documents. For example, here we see Hebrew palimpsest, which is the under layer, Arabic in the upper layer. Both of them are not really written in the same direction as we see, but we see kind of like some of the letters, the moment we extract the Arabic letters or the Arabic text, the Hebrew letter, it's faded and also fragmented when we need to overcome this. Now, several approaches have been developed in order to reconstruct this. The simplest one is using kind of manual reconstruction and practically trying to recover this really as a manual hard work. It's expensive and the time consuming and require really a highly trained expert. Automatic approach trying to apply a multispectral imaging. And for example, here we see example of multispectral images, and we'll be able to create kind of like several image at different frequencies, and in order and try to analyze each one of them separately. This approach is definitely interesting. The downside of it, it's expensive, both in the equipment of multispectral imaging are expensive and have limited availability for many people. Also, the image processing on this is also complicated because it's need to take into account the different frequency on this. Now, there is also a chemical approach, which is, I did not cover it here because it's often damaged the parchment, and we don't want to damage this parchment, even palimpsest, even part of it. Now, algorithmic approach, most of the algorithmic approach try to extract the text. And many of them, therefore, have a knowledge about the text, often what's written there, what's the style, and have a lot of information about the text and the handwriting style. And this assumption not always kind of available, and we can, or also doesn't hold always. And also most of the algorithms interested in kind of reconstructed the undertext, not really as the visual appearance of this piece of art before adding or scrapping and adding the upper layer. And this is what we are trying in this approach. We're trying to reconstruct the upper layer and to reconstruct the original manuscript before scrapping and adding and washing and adding the original text. And toward this, we used a architecture that follow the GAN scheme, and we call it the Palimpsest Manuscript Reconstruction GAN. And it actually aims to reconstruct not the text, you reconstruct the entire palimpsest and kind of, or the entire manuscript before scrapping and adding the upper layer text. So, okay. So we have used a dataset that consists of several kind of dataset. One of them is the DIVA historical database, which is a Latin dataset consists of 3 medieval manuscripts. We have the book of Al-Milal wal-Nihal in Arabic, and we also used a Hebrew pages from the National Library, mainly Sephardic Square, and I'll explain why we choose this Sephardic Square. We also use the Greek Syriac data set that exists in that publicly available. Now, in order to use deep learning models, we need a lot of data. Palimpsests are scarce and they are not really available for large quantity. And this is why we need to synthesize. In order to train these models, we need to synthesize a new patches for training. So practically we synthesize patches. And the synthesized patches came from 2 sources, one manuscript and the other one is palimpsest. Manuscripts are more available and we can practically play with them in order to generate palimpsest. Palimpsest exist and they are limited, and we also make use of this in order to train the model. So if we see, we started by creating synthesizing a data set from a manuscript. So we started with an upper level manuscript, for example, here Arabic. We binarize this manuscript and obtain a binary image. Then we extract patches from this manuscript, randomly extract patches. And also we extract randomly patches from other dataset that will act as the lower level. So in this case, for example, we have the upper level Arabic as a binary, and now we binarize this in order to not really to completely cover the entire text, but to use now the white background as a transparent color. And then we merge these 2 patches that extracted from the lower dataset, the lower page that acts as the lower level, and the upper binary image that will act as the binary image. And so, okay. So in this case, we managed to create from the Diva, and all of them have the Arabic upper level. So Diva have a Latin, we have 500 patches and 10,000 patches and 1,000 patches. This should be 5,000, sorry. And the Sephardic, we have a 15,000. Somehow there is a 10 missing here. And the Arabic book also, we have 5,000 and 1,000 for training. Here an example of synthesized dataset. So we have, will be the upper level layer, for example, and will be the both of all these are the lower level. And this is how we add the upper level because of the binarize Arabic into each of these patches. So this one after adding the Arabic will look like this as a palimpsest, and this one will look here as a palimpsest. Again, also here palimpsest, we play with different color of the upper layer, and that could be black and white. From palimpsest, we realized that all the palimpsest pretty much include, there was the upper level doesn't cover the entire text. Some parts of this text still appear and they are uncovered. And we utilize this in order to create actually new patches. That means here we have a patch that the original patch, we can use the upper layer from the Syriac to create a new patch that we know the ground truth, both the lower level and the upper level. And this is, we separate them and take the upper level text only, and then from the upper text and the lower text, we create new patches that combine from the Syriac and Latin in this case, which is both of them resemble exactly the same palimpsest, but now we have a ground truth. That means we have the palimpsest before adding the Syriac, the Latin before adding and after adding the Syriac. So our model is, as I mentioned, is actually based on GAN, which means have a generator and encoder. And the encoder encodes the reference patch into a latent vector. Then we use this reference vector in order to reconstruct the original palimpsest. So practically we have two parts. One is the encoder and the other one is the decoder, or the generator in this case we call it. So in this case, we give a reference patch. In this case, this is the patch before adding the upper level. We encode it into a vector L. So the encoder is actually by applying a sequence of convolution layers with kind of like also pooling and ReLU and all these kind of like a technique, but it's not really that many layers. This is what make it really compact, but I think it would be possible maybe to extend this. But the more we extend this model, the more training data set we need. And then after the last convolutional layer, we apply fully connected neural network in order to reach this vector. This will act as the reference vector. Now, the reference vector will be utilized by the generator in order to generate the original patch. So in this case, this is how the generator works. The generator gets the vector L as an input, the reference, and also which is not necessarily being from this original patch. The reference L is not this L, not necessarily. And this is what we give it a palimpsest. Again, apply several convolutional. Then we have a ResNet block, and then we have several kind of like going down this is pretty much kind of like fully convolution neural network. Then we go down in order to get kind of like small vector. Then we actually go up. So we have downside as kind of like convolutional layer until we get a vector. And then from this vector, we apply up convolution in order to reach back the same image. So this will be the training, the resulting image. So we train this model, and this is here we have the convolutional, we have the residual blocks, and then we have the residual ADA, BETSIM, IBN, and then we have the upper convolutional block and the RPDB blocks. So all these blocks are explained at detail in the paper. Now we train both of them. We train the encoder and we train the generator. Now the goal that to be able to now generate the original, what we refer to this as the original manuscript from a given palimpsest. So we compare this with a lot of algorithms, for example, image to image, translation, fit GAN, cycle GAN, pix to pix, and I will show the comparison results. So this is the main idea, that this is the data set we used for training, and this is the obtained results here. So the input is this palimpsest patch as an example, and this is the original patch, what we call the original manuscript, and this is the result of all these other algorithms. So if we see the dual GAN, we see that it actually did not manage to reconstruct the letters correctly. So here we have a gap, and also the VAV here is not really constructed correctly. Cycle GAN introduced kind of a noise that we see as a wave noise here, and the bicycle GAN, sorry, and the cycle GAN, if we see, it doesn't manage to construct some of the letters correctly. So we have the ein here is not really is deformed. The same thing with this kind of like part in the ha, which remain from the here yishbeh in Arabic. So it seems that this is the trace of this part remain here, and adding kind of noise that prevent actually clearly understanding this letter. Pix to pix is also doing better, but as see here, there is some noise, as it's kind of like a faded letters and incorrect kind of colors, white color here, and also still the trace of this upper layer and the lower layer is quietly kind of like visible. The same thing with VitGAN, we see that it has also another noise that we see it as kind of like dots appear somewhere. I don't know if you see this, kind of these dots appear kind of as, could be as maybe overfitting or something like a, maybe not overfitting in terms of the model, but maybe in terms of the resolution. But again, it include noise, and this is our result. So as you see, our result is very close to the original, and it has very little noise. Still kind of like there is, you see the influence of the kind of like the hidden part of the recovery of the hidden part of the ein is not really perfect. Another example. So here's a Arabic in top of Latin. And as you see, here is the same. Here we have the dual GAN is actually have kind of like really a lot of noise, incorrect reconstruction. Bicycle GAN also have a incorrect reconstruction of the letter. Cycle GAN has this, is now it's actually clearly visible, this kind of background noise, which is a, appear as a result of the influence of the pretty much the removing the this kind of the Arabic upper layer. You can see this as kind of like there's still track of this letter here. Pix to pix has a better result, but it still have the reconstruction of the letters has some noise. The same thing with noise in the background. FitGAN has, this is part visible, kind of like really clear noise of this kind of like dots like here, which is definitely not part of the reconstruct, and this is our result. So we evaluate our result in terms of like various kind of like evaluation metrics. We pretty much kind of like pose a kind of like noise metric, various kind of like metric that we have applied, which kind of in general kind of used in order to evaluate quality of images. And we also compare the quality of the letters by actually observing the quality of the gradient along the edges of the letters. And as you see, pretty much in most of these metrics, our result or our algorithm perform the best. Also, this is in the kind of like another, like in different data set. And you see pretty much in most of the metrics we perform the best. Now, some of these metrics may not reflect accurately the visual appearance or the human kind of vision in terms of comparing these results. For example, if we see the FitGAN, it's very hard to evaluate these dots as a noise because their percentage within the image is really small, so they don't really affect the quality, but we kind of like use all these metrics and compare them with the result of the model. Here is the kind of the result on the synthesized from Palimpsest. So as I just recall that we have this manuscript, we actually get part of this and create from the upper layer and the part that was not covered by any upper layer, we create patches for training. We randomly crop these patches. And this is the part which is without, and this is after adding a Syriac manuscript. So sorry, this is the part that was covered by a Syriac manuscript, and this is the result after applying our algorithm for the entire like block. So this was divided into patches, reconstructed, and then stitched back again in order to see the entire image. Now, if you see, in general, it was very hard for us to evaluate the quality of this. We consult with one friend who's actually working with the Greek, and she said it looks good, but it doesn't really give us any kind of like measurable metric in order to do this. So we used a Greek OCR that trained on Old Greek, because this is not modern Greek, but Old Greek historical document. And we compare the performance of the text recognition algorithms before applying our algorithm and after applying our algorithm. And we realized that actually on the tested, we train the Tesseract algorithm was trained to get kind of like on the training data set was about 90% accuracy. We run it on the data set before and after, and we get actually 4 times, factor of 4 in the recognition rate of the reconstructed manuscript. So in this, we not only managed to reconstruct palimpsest or the original manuscript of a palimpsest visually, that visually look or resemble the original manuscript, but also in terms of the reconstruct text quality is way better than the other approaches. So just to summarize and conclude, in what we have, they presented a novel approach to reconstruct the original manuscript from a palimpsest based on deep learning model. We used a synthesized data in order to train our model, and we evaluate on real manuscripts and compare it with the other algorithm that could be used in order to, for example, to reconstruct the original manuscript. Now, actually, we're working to apply this technique to a reconstruct or recover manuscript that's damaged by papers, by worm papers. Or like this is, we have there is at least I visited two libraries, one in Jerusalem and one in, actually two archive and one in Turkey, that they have a lot of like a manuscript that were damaged due to kind of like a, I would say lack of handling, or like this kind of paper worm that actually crawl through this manuscript and create these shapes. I don't know how much the result will be, but this is one of the things which is now I'm interested to apply this technique or other technique to recover these pages. Thank you. And if you have any question, and they told me that I have half an hour, so I'm trying to stick to this time. And
Thank you, Jihad. Let's thank our speaker. Questions? Yes, Daria?
Yes, Jihad, thank you so much. Very interesting. Why do you want to use it to reconstruct printed books that were damaged by the worms? Isn't it easier to, I mean, if it's a printed book, it must be a known text. Do you want instead to try it on manuscripts?
actually, you are this is exactly this is two images. I just grabbed them from the internet to show them examples. We are not interested in printed text. We actually, the two libraries has a one is actually in Jerusalem, has a handwritten manuscript in Arabic, and in Turkey also Al-Hassaniya library, they have manuscript also in Ottoman, which is the Arabic letters, both of them handwritten. But I was not able to get copies of both of them. And this is what actually now I'm trying to get the really copies of these, of the pages from these two libraries. Yes, I'm not interested in printed. You are right.
Thank you. Any other questions?
Here.
Yes, yes, Asa.
Yes, thank you so much. This is fascinating and it's cool also very much. I really liked it. I have two questions, if it's okay. One short one, if the concept of palimpsest, if we can treat, let's say, stacked layers of paper or parchment as a palimpsest and maybe read through layers that would waddle together. And the second question is more general, if you can relate to it, I don't know. How is the AI changes your research, if it changes the concept that you're thinking of or the tools that you're using, so to speak?
I think I will address the second question, then I will try to, I'll ask you to repeat the first question because I did not get it. So I think what all we are using right now is pretty much AI models. We almost every problem now we are trying to tackle, we try to develop a deep learning model or AI model or use existing model. Actually, recently, just yesterday, we get a result of extracting text line from Aramic balls. So they are spiral, kind of like, also there is a perspective distortion. It will be very hard using kind of like classical technique and also very noisy. And I think after training this, like with quite the same, not really very large data set, we managed to get a good baseline of these texts, and it has followed the spiral shape of this text line. The same thing with paleography and kind of like writing styles. It seems just to produce much better result than any other approach, and I think we'll see even. I'm pretty much like, I think we'll be able to reconstruct this kind of like the damaged manuscript. There is two questions. how many data set we need to train the model, how large these models, because this will determine the quality of the reconstructed images. Your first question was?
Yes, thank you. I wonder if, well, we have the problems of fragments stuck on one on top of the other, glued together, sort of deteriorated in wads, in piles. If you can think of this sort of phenomenon as a sort of a palimpsest and use these kind of tools to try to read through the parchment and receive some sort of text.
This is a interesting problem. As long as the kind of they are glue and you can see the one beneath, this is, I think we can apply this technique. But because it's exactly resemble the fact that the lower layer is faded and hidden, and this will be also faded and hidden. But if the paper was like the top paper was thick enough in order to heavily cover this, we will not be able to do it. Multispectral would be the solution to this.
Thank you.
Additional questions?
Yeah, following what Saft asked, I was wondering, what about turn the page upside down, the original palimpsest, so that you don't see the upper level, like the most vivid, but if you turn the page upside down, you have the original one. It's still very, very blurred, but it's supposed to be like more close to the other side. Can you understand? Like, if you have here the lower level and here the upper level, and you look from here and you photoshoot from here very carefully, you do the photoshoot, maybe that also can help manipulate the whole thing.
I actually have never seen a real palimpsest. I only have seen images of them. So at least I think the skin, because I read that some part of the skin they write in the two sides, which is in this case they are much more thicker than a paper. So, and the ink will not penetrate the skin to the other side often. This is why I think you can see palimpsests that have two sides. Now, my feeling that if you look from the other side, it's too opaque to see the beneath layer, because it's actually occupy very, very thin layer from the entire parchment.
You are exactly
Again,
right.
I've never seen one, and I don't know how this will.
You are exactly right. Parchment is an expensive material, and there are extremely rare cases when a text was written on one side only. The material is thick, and when you wanted to use it again, you either washed or scrubbed the original text and you wrote on top. So turning it the other, looking from the other side, you will just see another text. And then, so this is the problem. It's like technically it's one dimension.
I also have a question. How can we evaluate the quality of synthesized palimpsests? Like, how can we say that it looks like the real palimpsests and not synthesized?
This is a very hard question. I think we also face problems to evaluate the quality of the reconstructed manuscript. So it's very hard to, like, we use kind of like all these mathematical metrics, but I don't think they are accurately describe the quality of the reconstructed image. This question that we don't have an answer for the quality of the reconstructed image. If you are asking the palimpsest we reconstruct, pretty much it's kind of like there is a very wide spectrum of manuscripts like palimpsest, depends on the quality of the parchment, on the quality of the ink and the time and the storing condition. So pretty much we construct maybe in some spectrum, but if we construct the entire spectrum, of course not. But the really the hard question that we wanted to know is how to evaluate this. Even visually, maybe kind of people will look, but I think we need somehow maybe experts or somehow to be able to evaluate the quality.
Thank you. Yes, Dara.
I think what can be done here, actually, any paleographer can read a palimpsest if it's more or less well preserved. You need a special lamp. So if you can, because what you did is extremely impressive. If you could use some kind of technique to improve the readability of the resulting text, yes, when you extracted the lower layer, and maybe improve the readability of it, and then just to take a few lines and compare it to physical reading of the original manuscript with a lamp, and this will give you a very, very good indication.
But if you think about this as a piece of art, for example, like a painting, in this case, it's you want something that resemble the original, not necessarily like reading the text is kind of like there, because maybe you want another kind of features of the background, all these things. This is something which is a maybe artist could do something like this. I have a friend in New York, like a city, who is inherited from his father a large private collection of visual art. And he's actually showed me similar problem in painting, because if you look, they started with painting in a pencil and then they multiple layers, and he wanted to see if this is like, for example, what's the order of the painting. It's similar problem somehow.
Thank you. And this was my additional, whether you added some degradation when you stitched upper and lower layers, or you only use stitching like over.
No, we blur the images after like stitching everything together, because the upper layer is, the text is quite sharp, and we need to apply kind of layer to resemble kind of like the historical palimpsest.
Thank you. It was
the time for another question. Oh, sorry.
Oh, go ahead, Asaf.
Yes.
I'm sorry, everyone. I wonder about the end results that you provide your humanities counterpart. So if one is working together, what is the product that one receives? What kind of file? What kind of, I don't know.
Image.
Images.
We receive image. That means we actually subdivide the image into patches, process the patches independently, then stitch them together.
So simple JPEGs on one, or one can OCR or
Yes.
Okay.
If you have time, I have a question.
Yes, Biran.
Okay, and thank you, Jihad, for the nice presentation. And so, what's the utopia in the reconstruction of palimpsests? Is it to reach to the maximum possible OCR recognition, or to reach to the most original document?
There is two approaches. You're absolutely right, and it's, for example, for people who are interested in the text, they want to.
No, I mean in your work. I mean in your work.
In this work, we are interested in the visual appearance. We try to resemble the manuscript before scrapping and adding the upper layer.
Okay. But you
visually will look like as kind of like, imagine that just before holding this person who just before scrapping and washing it, and like how it looked at that point of time.
So how did you decide when you are creating the synthesized dataset? How did you decide that in the occlusion in how much amount it should be? I mean,
it turned out that the two manuscripts are pretty much of similar sizes. They are not really something that you will get kind of like, maybe could be at most one of them is double the other, but not really big differences. So this was the observation we applied. So pretty much we scale a little bit the text, like the upper text a little bit, but not really that much.
no, I'm not asking about it. I mean, now in the palimpsests, you have overlapping letters.
Yes.
But sometimes it overlap nothing. Sometimes it overlap the whole letter.
That's
so. How did you care about this?
It's kind of like here's the idea that it usually covers part of the letter, not really the entire letter.
Mm-hmm. There is a control on this in your
and
method?
the training model, we assume this letters, the same letter, appear in both in the training data set somehow with a lot of variation. This is why the model will be able to recover this based on the reference. The reference will encode how these kind of like letters or like the shape of the background look like. And this is why in the reconstruction, the reference is actually utilized in order to maintain this visual appearance. This is why we get complete letters and not really cut letters.
Mm-hmm. Okay, thank you, Jihad.
Okay. It's very interesting presentation and a lot of questions, which showed that the topic is very, very interesting. Let's thank our speaker again.
Thank you. Thank you very much. Okay, thank you.
Thank you, Jihad.
Bye.
Thank you very much.
Okay.